Hi, this is Pete Singer. I'm the editor of Semiconductor Digest, and I'm here talking to Winnie Nabea, who is with Mettler-Toledo, the Thornton group at Mettler-Toledo. And you probably know Mettler-Toledo. It's a very large company, close to $4 billion and 16,000 plus employees. And the Thornton Groups focuses specifically on ultrapure water and measuring various things such as resistivity, total organic content, and but today we're talking about silica.
Yes, I wanted to discuss this important topic of monitoring silica in semiconductor plants. As we all know, the production of wafers and microchip demands a high level of water quality. This is the reason why these plants have complex purification processes just to ensure that the water used in the fabs is of the highest and purity. So, though semi industry is not regulated, it is strongly recommended through the SEMI F63 0521 for the plants to use ultra pure water with silica levels less than zero point 0.5 ppb. This allows for plants to have UPW in their process that can effectively be used in their fabrication process.
So, Winnie, what is the importance of measuring silica in semiconductor facilities?
Yeah, that's a very good question. So, in the water treatment plant, silica is one of the most critical indicators of the health of the water system. It is one of the fast analytes that is released by the deionization systems, which might be referred to as either DI or demean or polishes by different plants. This occurs when the resin is approaching exhaustion and needs to be regenerated. So, if silica is not monitored, this can lead to contamination of the ultrapure water that is being used either at the point of use, the point of distribution, or in the tools. That's why it's of utmost importance to check up on the health of the deionization, either through grab samples, which we all know takes a long time, or by use of an online analyzer like Mettler-Toledo's 2850 SI.
So, what kind of issues will occur if silica is allowed to travel downstream to the fab?
Well, if silica breaks through, occurs, and it's not caught in time, the silica ions or particles can deposit and dry on the wafer surface. This will lead to defects during the fabrication process. Not only that, this cascades into production of either non-functional chips or chips with lower performance. Um, and also, not only that, so these defects they result in reduced yield. That means fewer chips end up being produced that meet required quality standards. And then another point to note is that with the higher defect rates and reduced yield, the plants end up incurring higher production cost, whether it be through time, the labor, or equipment. On the other end, it really impacts the plant's revenue stream for the company.
Then that impact certainly hits the bottom line.
It definitely does. You know, these plants are not in the business, in the water business, and certainly not in the business of losing their investments. So, understanding the complexity of the water treatment plant and ensuring critical parameters like silica are monitored, this alleviates a lot of these problems.
You mentioned earlier that silicon breakthrough occurs at the deionization system. So, where exactly should the plant be monitoring silica?
So there are a couple of measurements points where silicon needs to be monitored. As you can see from the diagram, the first part will be at the effluent of the ion exchange system, or DI system, located at the makeup section of the plant. And then there is the second measuring point, which will be at the polishing section of the plant. This will be at the effluent of the mixed bed prior to point of distribution. These are the most critical silica measurement points, but of course, one can go crazy and add other points. But at a minimum, these two locations need to be monitored.
Are there any outside factors that impact the water treatment plant and cause silica issues or decrease throughput performance?
Certainly, yes. There are other factors that may come into play. So, several plants actually do rent out their deionization vessels, and others use services of an outside company to sluice and regenerate their resin. So, in both situations, it is an outside service provider that is involved and needs to provide good quality semi grade resin. that has been regenerated and then meets the specs. So the only way to ensure that complete regeneration has actually taken place and to have consistent throughput, these third-party services or companies, they need to provide a certificate of compliance or conformance. So for the semi-industry, the two most important parameters that should be included in this certificate will be silica and conductivity, and the most important being silica.
What are the best methods of monitoring silica at these 2 points?
Um, so, a couple of the older plants were used to using surrogate measurements, and you'll still see that, like, they're still using conductivity, which usually do not detect silica breakthroughs on time. Other plants, they're still running grub samples. That takes a lot of time for the operators who are required to manage all the systems in the plant and then understand the implication of each parameter. So, without a doubt, the best way to monitor the deionization system is by using an online silica analyzer. The plants want to ensure that the water being sent to the fab is of the highest purity and meets the zero point 0.5 ppb spec. Not only that, when you're looking at an online analyzer, they should be able to meet not only these stringent specs, but provide remarkable accuracy, as well as reduce the maintenance cost and total cost of ownership to the plants.
So, how is Mettler-Toledo assisting semiconductor plants to monitor overall health of the water treatment plants?
I'll call this a small plug for a company. So, here at Mettler-Toledo, we are continuously working with different facilities to provide analytical instruments to monitor and maintain overall health of the ultrapure water process. So, whether it be conductivity, resistivity, there is TOC and pH and DO sensors. We also have analyzers for silica, sodium, and real time microbial measurements, plus other parameters. We have a full portfolio of instruments to ensure that the plants are confident with the water they are utilizing in their fabrication process. And within Mettler-Toledo, Thornton has been involved in the semiconductor industry for over 40 years and still actively working in the same industry. And the research that Mettler-Toledo actually did, conducted by Dr. Thornton and Dr. Morash, are they established actual resistivity values of ultrapure water, which is the current standard for the industry.
Do you have any other last comments?
No, I just wanted to thank you, Pete, for the time and for the support of Semi Digest and the platform that you have provided, not only to showcase our products, but to educate the end users as well.
Okay, well, thank you, Winnie.
Thank you.